All right, so this is going to be a video on the completing the square technique. And now basically what this is going to allow us to do is find an approximate solution to a quadratic equation. So if you remember before in the previous two videos, the first one was on the quadratic factoring technique, and it only worked if the quadratic expressions factored out. And the first one did, but the other two didn't. So we weren't able to use quadratic factoring technique on those other two. Then when we used the graphing technique, we were actually able to find an approximate solution to this second problem, this problem right here actually, this x squared minus 6x equals -1. But it was not an exact answer. The completing the square technique is actually going to help us find the exact answer to this problem, this x squared minus 6x equals -1. But before we do this example, let's actually go over how to do the completing the square technique. Okay, now in order to teach this, the first thing I'm actually going to do is show you what a perfect square polynomial looks like. So if you expanded out an x plus n quantity squared, how would that look, and then how that's going to actually relate to the completing the square technique. So here we go. All right, so the first thing I'm going to do is just start out with the x plus n quantity squared. Okay, so this is just going to be a perfect square of this x plus n term right here. Now, we're going to expand this out really quick. Let me change the color here. We're going to expand this out, and I'm going to expand it, and you'll end up getting x squared plus 2nx plus n squared. Now, so all I did was just basically did x plus n times x plus n. So I did x plus n quantity times x plus n, and then I distributed it twice, and then I ended up getting this x squared plus 2nx plus n squared. Okay, from here, I am going to relate this to what we know about quadratic expressions. Okay, in this case, the a, b, and c for this standard form quadratic expression. So a, b, and c. Now our a in this case is going to be equal to 1. Okay, that's really important. You're always going to want to have your a equal to 1 whenever you complete a square. Our b in this case is going to be equal to 2n, and then our c in this case is going to be equal to n squared. This will always, always, always happen whenever you square something that's x plus n quantity squared. Whenever it's that perfect square, the a, hopefully you're going to have to get it turned into a 1. In this case, we already had it as 1, so we don't have to worry about it. But when we actually solve certain problems with this, you're going to have to actually make sure it is 1. We're going to talk about that more later. The b is equal to 2n right here, and then the c is equal to n squared. The main thing that you want to see while doing this problem right here is that this b term and the c term are related, and how they're related is that c is always going to be equal to whatever b is if you divide that by 2 and then square it. Okay, so if I took this b right here, this 2n, and divided it by 2, I'd get n, and then once I square it, I would get n squared. That will always happen, and this is actually really important. Anytime you want to make a perfect square like this, you have to make a quadratic function, basically, that has a 1 for a, and then b, all you have to do is divide it by 2 and square it, and then you're going to end up getting that c that makes that a perfect square. Okay, now in order to use this technique to actually solve a problem, the best way of explaining it is kind of just to do a problem. So that's actually what I'm going to do right here. I'm going to solve this number 2 right here, this x squared minus 6x equals -1. I'm going to solve that using the completing the square technique, and hopefully it'll make sense on how to use completing square to actually get the exact answer for these quadratic solutions. Okay, the first thing I am going to do is, if you notice that on the left side I have just the a term, the ax squared, and the bx term, and then the c is on the other side. You always want the c to be on the other side if there is a c there. In this case, our c would be this 1 if I added it over. So I'm going to actually keep it on that right side. I'm going to show you other examples later where you have to kind of move that c to the other side, but you want the c to be on the right side. So you might want to write that down. Okay. Now, since the c is already on the other side, I'm actually just going to recopy really quick what is on the left side. So I'm going to write x squared minus 6x. Now, I want to make a perfect square out of this side. Okay, in order to make this a perfect square, again, I need to relate that I need to find a c term, basically. I need a c term right here, but it's got to be based on this b term, this 6. Okay, now if you remember before, at any time that you wanted a perfect square, as long as the a is 1, in this case our a is 1, all you have to do is divide b by 2 and square it. So that's what I'm going to do. I'm going to divide this -6 by 2 and get -3. -3 squared is 9. So what I'm going to do is I'm going to add 9 to this side right here. So I'm going to do plus 9, and it's going to be equal to, okay, I still have this -1 here, But since I just added a +9 out of nowhere, you can't just add a +9 on one side and not on the other. That equal sign means equal rights. You have to, whatever you add on one side, you equally have to add to the other just to keep the math even. Okay, so far I added 9 on the left and I added 9 on the right, so we're good to go. Now if you notice, this right here is going to be a perfect square. If you actually factored this out, you would end up with x minus 3 quantity squared. Okay, so if you actually factored out, that's what you'd get. Another thing you could do is if you just look at this middle term, you know this b is equal to 2n, and if you want it to be that perfect square, just divide that by 2. So I divided that by 2, and I got a -3 there. Okay, or you can just factor it if you want. Takes a little bit longer to do it that way, but you end up with x minus 3. On this left side here, I have -9, or I'm sorry, -1 plus 9, so this is just going to be equal to 8. Okay, now again, I'm trying to solve for x. So the first thing that I'm going to want to do is to get rid of that square. So to get rid of that square, I'm going to have to square root both sides. Okay, and whenever you do the square root, you're going to have to do the plus or minus in there. So square root it and then caboot it. Okay, this square and this square root are going to cancel out. So you're going to end up with x minus 3 is equal to plus or minus the square root of 8. Okay, now from here, obviously to solve for x, all we need to do is add 3 to both sides. So you have plus or minus the square root of 8 plus 3. Okay, now the general way of writing this, usually you just would write 3 plus or minus the square root of 8. So I just basically put this 3 in front, but that's just generally how it's usually written. So if you see it in a book, it's usually written that way. So now this is the exact answer to number 2. If you remember before, we had to use graphing technique, and we did not get the exact answer. If you actually plugged this into the calculator, you would get the approximate answers that your calculator showed you before when you used the graphing technique. So it's usually a good idea once you're done doing the completing the square to actually check with the graph to make sure that your exact answer matches the approximate answer. So I'm going to put these in my calculator right now, and you should get 2 answers. So 3 plus square root of 8 would be that 5.82, and then it just keeps going on and on and on and on. Again, that's just an approximation. And then if you do 3 minus the square root of 8, you're going to get that 0.17, and then it goes on and on and on. So it still matches the approximation, but this right here actually represents what the actual answer is, and that's the exact answer. Okay, so that's basically how to use completing the square technique to find an exact answer of a quadratic equation. Now we are going to be doing more difficult problems eventually that have quadratic equations where the a is not equal to 1, and we're going to have to divide that out. But we will get to that when we get to that. This is just kind of an introduction to what the completing the square technique is and how it can kind of be used to find exact answers of quadratic solutions. So if you have any questions about anything in this video, let me know.